I'm Jonathan Berry. I'm the Data and Digitalisation Manager at Western Power Distribution. So amongst other things, I curate, develop and deliver our digitalisation strategy, which crosses a broad theme of topics, which I'll touch on in more detail. And I'll say I'm a chartered electrical engineer, and I have a team of extremely bright data scientists who are driving some of our machine learning activity to hit our strategy. So I'll move on, and I'll quickly give a brief introduction into Western Power Distribution for people who might not be aware of who we are. So we are Western Power Distribution. So we were, about 12 months or so ago, actually bought by National Grid. So we're in a transition and integration period. As now a national grid company. So what are the key bits for us? So we serve 4 DNO license areas out of 14. So East Midlands, West Midlands, South Wales and the South West. As you can see, we have just over 8 million customers distributed via 185,000 substations with a huge amount of overhead and underground network. And another key statistic is just over 10 gigawatts of connected DG onto our network. So that's about 1.4 kilowatts of distributed generation for each of our 8 million customers. That, of course, doesn't mean that each customer has that, but on aggregate. And what I'm really keen to talk to today is about smarter grids and delivering net zero. And I think very briefly that highlights on the right-hand side the responsibility of WPD. And what is now key is the bi-directional flow of energy. This is, I'm sure well understood and by some great margin now, the flow of energy by localized and distributed generation onto the network, the need and value of data that we drive throughout the business and to deliver benefit for our end customers and wider society. And on the very right-hand side, it talks about some of the things that are key, and I'll talk about how machine learning is driving our improvements to both do the traditional things of keeping the lights on, maintaining, fixing and connecting our customers to the network, but also facilitating future net neutral market facilitation, resilience to the network, and drive competition and efficiency across the whole energy sector, and specifically the DNO network. So hopefully that's a useful introduction into Western Power Distribution if there was people who didn't quite understand what our role and remit is in geographic region. So I'll move on now to talk about WPD's digitalisation strategy, and then hopefully that'll link into how machine learning fits into that. So at the very top, as you can see there, is our need is to deliver net zero. So WPD as an organisation is committed to being a net zero business by 2028, and then support the UK government's targets of delivering net zero by 2050. So how do we do this? We'll split it up into 4 key drivers. So supporting our customers, our employees, our asset infrastructure, and ensuring that we are smart and flexible. So I'll talk a little bit more about those, but obviously the customer, our 8 million customers, are absolutely at the heart of everything we do. Our employees are the key facilitator to delivering and driving for our customers, whether that's office-based, doing design and planning and customer contact and interaction, to the endpoint field engineers who are restoring supplies and connecting new supplies, how we digitalize their experience, how we use data and drive efficiency and effectiveness for those infrastructure. So we have billions of pounds worth of assets and 185,000 substations with connecting overhead lines and underground cables. How do we use data and use machine learning to drive insight from those, making sure we are optimizing our intervention techniques and our reinforcement and our maintenance activity to make sure it can do as much as we possibly can, as effectively as we can. And then smart and flexible, I briefly talked about neutral market facilitation. So how do we get the most out of the network, and how do we enable customers to get the most out of us through DSO flexibility services, and being flexible how we operate the network. So I'll talk about some examples of what we've done around machine learning to drive that and what we're looking to do. So how do we effectively do that? So I'm absolutely obsessed with the 3 core pillars of our governance. So people, we need the right people, both internally and expert consultants that work with us. We need to educate those people, reskill and retrain and get new skills and training in. processes. So we really need to reimagine and change the way we work and how we operate. Going digital and using data and driving machine learning activities isn't about taking a manual, analog or paper-based process and digitalizing it. It's at the core of thinking, how do we change and how do we drive what we need to do for the future, and how do we drive that successfully? And then finally, it's really leaning into technologies. So not working within the bounds of what we have today, but working in the bounds of what is possible and taking leading edge technologies to deliver that. So there are 3 governance principles. And how do we approach this? So data management, and I'll talk a little bit more about how machine learning is supporting our data management activities. Insight and operations, so understanding the network and driving improved performance. Again, I'll talk about how machine learning can drive that value for us, and then delivering for stakeholders. So all of this is nothing if we don't drive better performance, better operation, and better security, reliability for our stakeholders that are connected, but also third parties who are interested in what we're doing, how we're doing it to drive value for their strategic aims as well. So I'll talk a little bit more about that and what's net zero and what's changing. I've briefly touched on, but I'll move on to the next slide and I'll talk about some of our wider drivers, needs, and what's coming going forward. So left-hand side, you can see 6 things. And, today is probably yesterday and tomorrow is today and beyond. In reality, there's a huge change in the power generation structure from a centralized model to a decentralized model. The same with the electricity market. Huge flow in the transmission network about regional balancing of supply and the data that's required for that. I've already talked about the bidirectional flow of energy at the distribution level. We've got a huge amount of data and visibility that is becoming and should become available through smart meters for our customers. And importantly, our end consumers are changing. Their needs are changing, both in terms of their reliability of electricity, their expectations, their understanding, and the technologies that they're employing. And a brief example of that is a couple of projections out to 2050 of the number of both electric vehicles and heat pumps that are coming onto the network. So this uses National Grid ESOs for energy scenarios, but these are WPD specific in terms of volumes and predictions. And actually, I'll talk a little bit about how we use machine learning to drive the insights for this. So you can see, from a relatively small number in the grand scheme of things, from electric vehicles up towards beyond 10, 11, towards 12 million electric vehicles on the network, and heat pumps towards 6 million heat pumps on the network by 2050. So we need to use data, use digital, use machine learning techniques and other digital techniques to drive value, to minimize the cost and maximize the value and expectation of our network. And that's what me and my team are hugely focused on. So I wanted to now talk in a little bit more detail about machine learning, what we're doing to use machine learning to drive a smart grid and to drive towards net zero. So I thought it'd be worth picking up on the next slide, a brief explanation of machine learning, and I make no apologies that I directly lifted it off the first sentence of the machine learning article within Wikipedia. And sometimes you have to take Wikipedia with a pinch of salt, but I think this does a reasonable job. So I don't propose to read this out to people, but essentially, machine learning and our definition internally and understanding is about building methods that learn. So what do we mean by learn? Take historic data and today's data to drive value, to optimize a set of routines or processes to drive insights going forwards. And what we mean by learn is articulating and refining a model with the greater amount of data you have to test it on. So what's actually happened today to predict tomorrow, or to understand data in this scenario matches a historic scenario, and how we use that to leverage insight and value. So predictions or decisions, as it says there, is the aim of the game. And one of the we are making a huge effort to improve the amount of data we've got, improve the processes we have. Lots of machine learning is about filling those gaps for us and driving insight at a cheaper, faster scale than it is to do some data fixing. And I can talk about that in a little bit more detail. So on the next slide, I'll talk about why why do I think we need machine learning, and then what do we need it for specifically? So I've really bound this into 4 key areas. So I've talked about customers, our 8 million customers and the customers beyond, being at the heart of what we're doing and why we're trying to drive digital transformation throughout the business. So customer interactions and insight. So what do I mean by that? Well, using data to understand how we best offer services to customers, how we best interact with them, whether that's people that are off supply or whether it's vulnerable customers or whether it's new connecting customers. How do we create those optimal interactions and insights so we know as much about the customers and we can provide a tailored experience to the customer's ends needs? Yeah, data quality improvements. We have a huge amount of data. Like lots of companies, we have significant gaps in that data. So how do we use machine learning techniques to drive data quality and completeness improvements? That's lots of standardized and tried and tested methods. The value of that is increased certainty around data means we can provide increased certainty on the decisions for our customers, for our network, for our control and operations. That then leads into the 2 bottom points. So network investment optimization. So understanding what's happened historically on the network to understand when should we maintain, when should we interact, when should we replace, when should we increase the scale and volume of the network. So this isn't about necessarily about reducing the cost, but it's investing at the right time for the right set of circumstances. And that's very hard to do manually. Putting automated digital machine learning driven processes in can really target our investment, providing effective and efficient delivery. That then leads, so that's in the forecasting and forward-looking view of the network. Operational optimization. So how do we optimize the network in real time? How do we make sure that we're moving towards a balancing of load, understanding that we can move and reconfigure the network as we expect generation to grow? We can use detailed and sophisticated machine learning techniques. And I'll talk about one of the actual examples that we have as part of our live environment now is about when we lose supply, being able to reconfigure as quickly and effectively as possible to minimize that disturbance onto customers. So there's a huge plethora of value to be driven by machine learning and more widely using data and digital products to drive delivery. But I see a real value chain in concentrating on those 4 key areas. So I'll move on now to briefly talk about what we've done. So yeah, how have we used it to date? So we have a number of examples of how we've used machine learning to strategically and tactically deliver benefit in real terms for our customers, for our network and our operations. So we do have more examples than this, but I thought these were 4 really exciting opportunities to share in this environment. So yeah, we have over 2 million of our customers now have smart meters. What that means is we can understand when they are and when they are not connected to the network in terms of if they have voltage or not. We now ingest this smart meter data into our control and contact center systems that act as if somebody has phoned us, so we can use this data to more quickly understand when our customers lose supply and re-energize them more quickly. So we're now, in some instances on our LV network, historically, all DNOs waited for a customer to make contact that they'd lost supply. We now have increased our visibility through smart meter data, and we use machine learning techniques to aggregate the data points to say, yes, this looks like a fault on the network, or it looks like an individual fault. So that's a huge value to us and our customers to work to re-energize them quicker. So yeah, really proud of that example and the guys in the team delivering that. Next one, self-diagnostic of optimal network reconfiguration post-fault. What does that really mean? So if we get a fault on our 11 kV and upwards on our network now, what we have is an automated system that looks at the network, what was happening pre-fault, what's happening now, and what's likely to happen when we do a reconfiguration, and it provides the optimal reconfiguration to the network. What does that mean? That means that we can use historic network events, historic fault data to understand how we can reconfigure the network now to reduce that burden of the fault on customers, i.e. reduce how many customers are affected by that fault. Historically, people would do that manually, and whilst humans make great decisions, they don't often make the optimal decision all the time. So looking to take that out and have an audit and control process is hugely important to us. So next one, short and medium forecasting to inform optimal operation of the network. So using historic events, third-party data to predict what's likely to happen next on our network. And I'll talk a little bit more about that. And then show some of those graphs. So using long-term forecasting of LCT from third-party data, what's happening, what the rate of change is, to look at our longer trends and forecasts. So they're split across the different use cases and drivers for our network. Therefore, hopefully real tangible examples. So we've done lots. We need to do lots more. So if I'll move on to the next slide, and I'll talk about what I think is really important, which is about creating a community for data, digital, and importantly, machine learning. So I talked about technology, process, and people before, and the ownership, accessibility, security, quality, and knowledge, which needs to come with that for a structured data governance, and specifically about machine learning, and put our trusts in essentially an augmented box that makes decisions for us. And what I really mean by creating a community is not working in silos, either within organizations or within a sector, but going beyond that to leverage skills and capability. And I really wanted to do a call out here on some of the work that we are doing, which is we have a GitHub, an online data science environment where actually we've started sharing our code so other people can use our data or third-party data and use the code that we have. So one is time series forecasting models for short-term predictions of our demand generation and import on the network. And I think this is hugely important. If we all try and do our own things, we'll never get optimal driven solutions. So this for me was a call out to increase collaboration and communication within the energy sector and beyond that. So what do we need to do next? So I'll move on and for us as an energy sector, I think what we really need to do is as I've spoken about, expand collaborative delivery. So going beyond a single organization or departments within an organization, working with organizations that their heart and soul is in machine learning, sectors that have already used this to a greater extent than us, and organizations that have that understanding. Increasing the relevant skills within the sector. This is new. We're largely organizations full of highly skilled and qualified electrical engineers or gas engineers, depending on which specific part of the sector you're working. What we need now is people with computer science, data science skills, wider IT literacy and knowledge. Delivery focused on targeted outcomes. If we're not careful, machine learning could be it should always be fun, but it can be very fun to learn things that come out and spin off through spurs of learning. We need to focus on targeted outcomes that deliver for the network, our customers, and our wider effectiveness and efficiency. And what we need to start doing is to scale from bespoke trial solutions to enterprise level solutions. And that's not to say we need to buy huge monolithic solutions, but actually make sure we've got scale, productionized governance, auditing process to build trust. Trust means that we can build reliability and maximize and leverage the value of these systems. And then I'll move on to my final slide. So what's next for WPD? So this is a bit of a call out for our digitalisation strategy for delivering digital into our ED2. So the next price control period for us between 23 and 2028. And a huge part of our machine learning activity falls within smart and flexible. So looking at some platform levels around machine learning, getting greater visibility from our smart meters and using them to optimize our planning capability. And as I've spoken about, state estimation platforms. So there's always a healthy argument about machine learning. Is it just mathematical, statistical modeling? We have three diverse work streams here, which are interlinked, which, as you can see, I won't go through them now, but deliver targeted value and benefit over the 5-year period from, just calling a couple out: automated network analysis functionality, flexibility management systems, and then we will, I've purposely not touched on it much here, but a transition from some of the machine learning activity through to what we believe could be more genuine AI, and there's the benefits there. So if you'd like more detail on that, either reach out to myself or take a look at the digitalisation strategy. And that's the end of my slides. Hopefully that's been useful. And if people have got any questions either now or later, I'd love to hear them.
Hi, John. The one question I have is, Western Power Distribution are confident that it, as a business, will reach net zero by 2028. How exactly are you doing that?
Yeah, so that's a really, really good question, and of course I'd sort of push you towards our well-justified ED2 business plan, which talks about this in more detail. What are we doing and what have we done? So lots around efficiency of our buildings and operation, putting greater generation and storage functionality to make those net zero. We're going through a huge process to electrify our fleet. We have a huge number of vans, as you'd imagine, so moving towards an electric fleet where it's absolutely possible. So we have a small number of vehicles which currently don't offer electric alternatives, but most like the Ford Transit van and electric vehicles, moving towards that. Different working methodologies to make sure that we work remotely and drive value and efficiency, and a huge raft of environmental factors around the assets and the operations that we have on our network. So an increased program of some of the SF6 gases on the network and how we replace those as assets to drivers. So it's really a mix between the assets and the operation part, and then the functional delivery part of our business to get there. Yeah, Jonathan.
One thing I wanted to ask is whether or not your opinion, will the UK reach net zero by 2050? Do you think it's possible?
So I definitely do think it's possible. I think we need, this is a bit more wider and existential. We need just connecting distributed generation to the network and transition to electric vehicles won't necessarily get us there. It's got to be an integrated value chain from the generation all the way through to the supply business. And what's really important for us is not to be considered in silos of energy sector. So we can't have electricity, gas, water, transport, waste, for example. We need whole system strategies to look at what the optimal solution across those multiple sectors are to deliver that. So it's absolutely achievable. We just need to make sure we do the right things at a whole system level, not at a specific energy type sector level for me.
And what challenges do you think are coming from the electrification of heat and transport?
Yeah, so the very simple challenge is increased demand on the network. How we do the right things without quadrupling 6-10 times putting the level of assets into the network. That's a huge part for us. So how do we increase how smart our network is, how flexible it is, and how dynamic we are to the needs of the customers? In my role, I would say that comes from putting new digital products that are customer facing. And one of the strategy elements I'm really focused on is empowering our customers. So putting the power in their hands. So we're doing a whole program of work around self-serve functionality, specifically at low voltage, and putting low carbon technologies in so the customers can take the initiative and as they are doing, and drive that value for themselves at the right time and not having to wait. So it's about us changing our processes and culture to make sure we're even more customer focused than we already pride ourselves being today.
There's been huge demand for electric vehicle chargers, like rapid chargers on, motorways and in key areas. But is the grid ready for this rapid installation of these chargers?
So yeah, we're doing lots to make sure we are ready. So we have a real exciting innovation project called Take Charge, which if people are ever near Exeter service station, they've just installed the first package type substation to facilitate rapid charging at scale at motorway service stations. So historically, it would have taken a long time to connect a new substation for that size and that sort of environment. This is a different type of design, which means it was installed within 2 days and is now ready to go and operate. So what we're really doing is all the way through from our innovation program to our BAU program is making sure that we have that right strategy. We feel that Each electric vehicle charger is looking at 35 kilowatt hours. We have enough capacity on our network. It's about how we manage that. If everybody wants to do everything at the same time, that's where we have difficulties. And it's around using data to drive value, to inform and work with our customers and work collaboratively with suppliers and that whole energy system again to deliver it.
Perfect. I think that's my final question. Otherwise, it's going to be just like 20 questions that I have. I don't know if anyone in the audience has any questions. Currently, we've had none through, but obviously this will be recorded, and hopefully people can reach out directly to you if they have any further questions.
Sounds good. Thanks ever so much, Jordan.
Perfect. Thanks for joining us, John.
Thank you. Bye.